Good morning. Gave everybody a couple of minutes after 9 to get started. I'm Brian Green from NeuronSphere. I'm here this morning with Kate Walls, and we are going to talk about the NeuronSphere Librarian. The title of this is, the NeuronSphere Librarian, better than S3. I mean, kind of a marketing hook, right? Like there's an S3 bucket right in the middle of this thing. We're definitely going to use S3. But I want to talk about some of the challenges that I found with using S3. It's a common thing that I think if you're on AWS, right, and we can talk about how this applies to Blob Store. But if you're on AWS, you're probably doing this shared file system kind of pattern on S3 where you've got a couple of apps or maybe a whole bunch writing into some buckets. And this path-like structure up here, we're going to talk about this and use this as an example. What you often end up with in S3 is a lot of people that need to collaborate on the conventions in the string path for the objects and what they mean, right? So we're going to dig into that in a minute. There's some other challenges with S3 that we found, particularly with large files and sort of pseudo-transactional use cases. So a remote client starts a large file upload, a couple hundred megabytes over a slow network connection. They get part of it in. And then it fails, right? So what does that look like in S3 and how do you identify it? What other people can see it? Maybe there's security concerns above and beyond what you want to do with IAM. And then the big one, the big one is querying, right? And how do I find things later in S3? I think we've all spent lots of time writing different scripts that do parsing and listing and then filtering to find different collections of values. Really painfully inefficient, right? And there's ways you can kind of do some stuff with tags and et cetera, but searching, almost always becomes a challenge. So we're going to talk about the librarian, how it's built. We're going to run through some bullet points over here. I've got to make sure, that I remember to talk about some things. So in our previous demo, Alex covered semantic microservices, right? You define a semantic model and then you build a service around it. And if you want, you can extend the infrastructure and extend the storage and do some fancy stuff. So he showed a very simple example. We use that same framework to build the librarian. So, first thing to note is the librarian is just another NeuronSphere microservice. The APIs will work the same way. The security will work the same way. The extensions will work the same way. How it, deploys, et cetera. So that's also why we see this Gen client right here, right? So we've got the librarian microservice. We've got both Python and TypeScript clients that have been generated here. And, there's some basic APIs. We've actually got a bunch of custom operations. So yesterday we saw a simple one. We have a bunch of custom operations in the librarian. This is the first time we're going to really dig into this idea of service local microservice storage and how we blend that with shared storage, okay? So there's, we've got the dotted line around. This is the actual librarian. It does manage a bucket. So there's, everything you can do with S3 kind of behind the scenes here, but we do provide a different API surface in front. And we're going to talk about access URLs. Additionally, the librarian can automatically provision a secondary region replication bucket and manage a bunch of replication policies. It has tenants for versioning and all kinds of sort of the standard stuff you'd want to configure. So let's talk about how do we get stuff in and out of S3, right? Usually we get stuff in and out of S3 by giving some clients some accounts and letting them, put stuff in paths. And I mean, we do fancy stuff with IAM. Maybe we're trying to protect different paths. But really, it's often kind of a free-for-all, right? Because this is just a string. Right? It's a valid key, valid path. S3 really doesn't care. And so you can end up with some kind of wild stuff in there. Additionally, there's this argument that says you shouldn't really give things direct access to S3. Like ideally, what you would do is put an API in front of it and only hand out access URLs, right? So that you can do security and authentication or authorization rather above IAM, right? And you're not really, there's other fancy stuff like putting prefixes in the paths if you want. So using access URLs, it's a thing you should do, right? But natively, what do we often do? When natively, we just have a bunch of people connecting to a bucket and kind of moving stuff in and out, and then writing these weird scripts. So the librarian, one of the things that is critical about it is we don't give people access to S3 anymore. We don't give API access to it. We don't give console access to it. The access you get is via the librarian API, via its extra security layer, and you're only getting access URLs in and out. So you're getting timed access URLs both in and out, which is a critical thing if you want to manage the security of this at scale. So let's look at a file. I'm going to upload a simple file. It was last December that we wanted to upload, that this file happened. And dev123, and because I work for a device company, I recognize that's a device serial number. And because I, kind of work with computers and oh, this is a date, right? Okay. Particularly, this is an ISO formatted date. We call these ISO dates specifically so that people understand it's not only a date, it is this specific format. We have this thing called devrun11. We know that that's a particular object in our domain, right? Maybe it's related to devices. Then we've got a category in here, and then we've got some files. And you see this all the time. We have conversation, usually not a lot of people have a conversation, sort of the earliest folks that are building some of this stuff kind of come up with a convention here, and then on you go. And maybe later you figure out it's really hard to figure out where everything is. Maybe we should have a little database or something that kind of keeps track of stuff. There's already a lot of people reading and writing directly. We've already got lots of weird search scripts going on. It can be challenging, right? So what we want to look at is instead files always really belong to real objects in the domain, right? Like this path is a string prefix to this file in S3, but realistically in our mind, we look at this and we say, well, this belongs to a date. And anything under this hierarchically belongs to that date. And anything with device 1, 2, 3 that's in this position, well, that's the unique serial number for a device. And we know that by convention. So what we really do is encode tons of information into this path and then kind of pray everybody knows how to use it. It's really like the loosest non-existent data contract that you could imagine for sharing data. So what do we do with the librarian instead? I'm going to switch over really quickly to this screen that Kate has shared. And I'm not going to drain this extensively, but this is the librarian configuration for the librarian that Kate is going to demo for us. And so you can see a couple of paths. So we're going to define paths hierarchically. So we're going to try to do a pattern matching. It looks like this path first. It looks like this path next. It looks like this path next. And we're actually going to define, okay, if you upload into this path, these are the relationships that you're going to build. And when I talk about these are the relationships that you're going to build, we're talking about relationships all the way down here in the global graph, in addition to service local storage. So your file is going to come in, and Kate's going to talk in a little more detail about this sort of pseudo-transactional layer that we add with these clients, because we're going to have you do a put, and then we're going to let you work, and then we're going to make sure the transaction is closed. Kind of a common pattern. And when that's closed, we're going to have inferred looking at this path, and we're going to put the content item here, but we're going to create relationships down in this global graph. And we're even going to create relationships to objects out in these other services. And this is going to allow us later to do queries. And this is the, hey, I'd like to do, find me all of this category that belongs to a given device. And writing that query against S3 tends to be kind of annoying. Writing that query against your graph database, right, and hidden behind the librarian API, you can query the object domain the way you think about it. And what happens is you run this graph query, and that resolves to the set of content items that are ultimately related. And now you're going to get your access URLs to the content items that you're interested in. But we're going to do most of our searching against, we're going to do some of our searching against service local storage. So when we want to find things that transactionally aren't complete and haven't been shared with the world, we're going to search here. And then the API will automatically, the librarian will automatically defer down to the global graph when it needs to search for that. We won't talk a ton about entity-driven security, but one of the things that this opens up, we'll cover it in another demo, is beyond IAM and beyond path-based policies, this allows you to define security policies that are actually based on your object graph. So when we talk about attribute-driven security and true data-driven security, this puts a layer on top, a policy-driven layer on top that can use your real object domain, real entities, real attributes. So, devices made on Wednesdays could have different security because that attribute is available to your policies and to your queries, even though it's nowhere in this string, in this path. So the search you want is rarely in the path. Kate's got a bunch of searches. Now, I talked through a lot of this because this is an API. There's not a huge user interface to it. So what we're going to do now that we kind of understand it is we're going to switch over, and Kate is going to run our small integration test suite. So we have a small test suite that is going to demo a ton of the API operations. She's going to look a little bit more at the, yesterday we saw a little bit of a semantic model. She's going to show us the bigger semantic model that ships as standard with the librarian. She'll talk a little bit about the extensions that we're using for devices and cases. And then she'll run a bunch of files through and a bunch of queries through. So without further ado, we're going to switch over to Kate.
Awesome. Thanks, Brian. So as he mentioned, I'm going to run through our integration tests, and what this is going to do is verify a lot of basic functionality, but also give me a test set of data that I can then run searches against and kind of demonstrate some of the power of what's going on with our librarian service. So I'm going to let this run in the background. This is using our test automation component Bender, and it is running against a deployed librarian in the cloud. Just our component Bender is going to run locally for now. And in the meantime, I'm going to bring up the docs here. This is our documentation that comes prepackaged with our librarian service. And I want to drill into a little bit more about our content items as our basic object in our schema here, and talk about what it takes to actually upload a content item. And Brian alluded to this a little bit, but I wanted to show this diagram here that kind of demonstrates what's going on under the hood when it comes to uploading a content item and what makes it a complete upload. So if you look on the left-hand side here, we have a basic client. Now this could be a user, it could be a librarian sync agent, or it could be code directly installed on a device, wherever we want to upload file content from. This over here is going to represent our librarian API layer, and the store here is going to represent S3. So the first thing we'll do is call our put API operation. That's going to create some basic metadata about a content item. And most importantly, it's going to generate that temporary upload URL from S3 that we can then use here to actually put our file content and return an upload status. That upload status can then be returned, calling our close operation. And what that's going to do, the librarian will take that, it'll check that there's actually a file in S3 where we've pointed to, and assuming there is, it'll return a successful status as well as some other metadata like the size of the file that was uploaded, and indicate that that upload has been successful. In addition, so this is just all about the content item itself. Brian alluded to, we have several path components that actually get mapped to different entities in our schema. So I wanted to drill down briefly and take a look at, this is our core librarian schema. So you'll see here, everything draws from the content item itself. We've got some attributes like the content item path, which is directly related to our S3 path, as well as the file size, when it was created, some upload information, the status, all of that. And it's going to have several outgoing relationships to those different path components. First is a content category, which is kind of our basic categorization for content items, as well as a content item type, which every content item has. It indicates not only the type of file that it is, but where it was generated from generally. So it adds a little bit further definition in how we can distinguish different content items. We also have a content item event. This is going to correspond directly with those put and close operations that we're calling. So we know what has been done and how often a content item has been uploaded or updated. We also have the NSData entity that is going to represent our ISO date, that first path component. And we also have some tagging that we can apply as needed to further categorize our content items. And so I'll show, while our tests are still running in the background, I'm going to show a completed set of test cases. This was run previously, and kind of just explain what it's doing in the background here. So we've got two different test suites. This first one is going to put a single content item verify all of those relationships and everything about it, and just ensure that all of that functionality, it's going to prove out what we're talking about actually works. And then the second suite here is going to put several content items and show the capability of our librarian search. So I'll just briefly talk through all of this. We're going to call that first put operation, create some metadata about a content item, give it a path. Once that's done, we're going to verify all of those attributes are what we expect, including the content item path. We're going to verify that it has a status of created and that currently it has no file size because we haven't uploaded our content yet. And then if you look here, this next set of tests is going to verify all of our relationships. Now, a lot of these should look similar to that core librarian schema that I just showed. We have one event, content item event with type put, because we've called our put operation. We also have one category that was mapped from the path. We have one NSDay. We have an addition, as we're looking at, this is actually an extension of our base librarian service called our device librarian. So Brian alluded to that a little bit, but it's actually going to have a relationship to a device that has a serial number as well. And additionally, a device run, which has a run identifier. And once we've verified all those relationships, we're going to upload some data using that upload URL that was returned from our initial put. And we know exactly what that data is. So we'll actually verify that that was uploaded correctly as intended. After we upload the data, we're going to do a content item close. That's going to close the loop on our upload process. And we're going to verify, once again, the attributes that come back, including the status. You'll see what we call it is closed with file. That indicates that the upload was successful. The content item is now closed and it has file content that's available in S3. So we'll verify that. We're also going to verify the size of the file bytes that are, or the bytes returned. Since we uploaded the data that we've known, we know what size it should be, so we can verify that that's correct. And we'll verify, once again, it has now another relationship to a content item event, but this one is type closed. So we'll see, we verify it has two now, both a put and a closed event. And then we're going to do some basic searching here. This is just going to search based on the content item path. We'll get returned a download URL that we can then download the data from the content path. So we get that here. We save the download URL. We download the content path and verify that the data matches what we originally uploaded. So we know that our file content has maintained its integrity through the whole upload process. And we did this all searching through the content path, which, understanding how S3 works, that's going to be a unique identifier for the content item. But we also have a global unique identifier, which we call a NID, or NeuronSphere identifier. So we can also demonstrate here that we can do the exact same thing. We can get the content item and download it using that unique identifier as well. And this last one is just going to use one of our client library operations to do that whole thing all in one go, where it'll retrieve the download URL and download the file and make it available locally, all just using a single call where we pass that global identifier. So that covers our first test suite here. We've really gone in depth at that point with a single content item, and this next one, as I mentioned, is going to go a little bit more in depth into the search capabilities. So we're actually going to start out by putting 10 files. And when I say put, this is not the simple librarian put. This is actually a call to our client library as well that will encompass all three of these components. So it's going to call the put, it's going to upload some file, and it's going to close it. So it's going to be available to search through our global state store. And you can see here we've got a variety of different ISO dates, serial numbers, device runs, categories, as well as different content item types here. And you can see here our categories kind of align to what type of file it is. This is just one example of how it can be used, versus when we look at the content item types, it indicates not only the file type, but that it came from a device versus, say, an instrument or that a zip file represents application code versus configuration files. So just to kind of demonstrate the difference between our content item types and what they represent. So the test is going to run several different searches and verify that we get the expected number of content items back based on these different paths that we've uploaded them to. So the first thing we're going to do is search by a named query. This is a configured graph query that we can just pass some parameters to. In this case, it's going to be by content item type. So that's going to look at our related content item type entity and find the content items that have a relationship to that type. And we're going to start by searching by JSON instrument. You can see here we have a couple of these, so it's going to verify that there are 2 returned. The next one it's going to look at is our JPEG device. Once again, you can look up here. We've got 1, we've got 2. So it's going to verify that 2 are returned. The next one it's going to look at is zip application. So we just picked a few of these. You can see we've got 2 here. So we've got 2 returned from all of these. So that's working as expected. The next thing it's actually going to do is verify all of our expected queryable schemas. And this is important in sort of building out a search tool on the front end where we can know which attributes we can query by, but also it'll demonstrate beyond that core schema that I showed earlier, it'll show some of the extensions that we have for our device librarian. So
yeah, so hang on, I want to make sure that one's really clear. So from an API standpoint, this is a discovery endpoint that is giving you schema information so that you can completely cover the sections of the graph and relationships that are in this particular librarian, right?
Yep.
Okay.
Yep, exactly. Yeah, so you can see here, these are the same entities that I showed on our schema model before. So we've got an NSDay. You can see these are all mapped to Lang librarian. This is our core librarian schema. We've got a content item, an item type, and a category. In addition, we have some schema objects from our device namespace. So since this is a device librarian implementation, we can also relate content items to a device with a serial number, as well as a device run with a run identifier. Next, what we're going to do here is pass some more advanced search queries. So you can see here, the first one that we're going to look at is looking at anything with an ISO date less than December 1st, 2022. And we can go back up to here and see we've got several that are from February 2022, and that's what this is going to point to, is all of these that were created before. This is non-inclusive right now. We could pass like a less than or equal to, but in this case, we're just looking for everything less than. So we're going to get those 4 content items back that were mapped to those February dates. Next, what we'll do is combine some different search parameters here. So we're going to look at content items that have a device run identifier of dev run 21. And this is actually reaching out to our case namespace at this point. You can see here, we've got a few content items mapped to this device run. So we expect those 3 to be returned. And actually this next one is where we're going to start combining our search parameters. So we're going to use that same device run 21, and we're also going to look for content items that have a type either JPEG instrument or zip application. So if we go back up again and look at these, we've got 3, but we've only got 2 that match either JPEG instrument or zip application. So we've narrowed it down a little bit further. We're only going to get 2 back at this point. And the last one here, we'll pull in some of our entities from the device namespace. So we're going to search a serial number as well as a content type of JPEG instrument. We can go back up here and see we've got a couple different devices referenced here. And we're going to narrow it down by content item type as well. And so we're going to expect 2 to be returned. So that demonstrates some of the capabilities of our librarian search. As Brian had alluded to previously, and what I'll touch on briefly again, is this upload process. So when the first put operation is called, it's really just in a created state. And so it's only going to be available in our local librarian persistent store. Once it's actually closed and the file is uploaded successfully, at that point, it's going to be available to our global graph store. And that's what's going to make it available to other services and enable some of those more powerful search capabilities. So I'm going to check on our tests over here. You can see everything passed. These all indicate those same test cases that I just went through. So we did all the verification of our content item as well as all of the search capabilities. So at this point, we have all of those same files that I just showed over here available in our global graph database as well as in our librarian. They have paths in S3. So I'm going to demonstrate a little bit what it looks like to query our graph database directly. And so I'm connected to the global graph store, and I'm just going to start out with some basic searches just to demonstrate, first of all, that all of these content items are here.
What kind of queries are these? What language is this?
This is Gremlin query language or GraphQL.
Aha. All right.
So you can see it looks quite a bit different than, your normal SQL statement. I'll step through it quickly. I'm just going to be looking for all of our vertexes or vertices with a label of content item. And then I'm going to just pull out the content item path and identifier so it's a little bit more digestible. And you can see here, this lines up with the data that we had just uploaded here. I'll just prove that a little bit. And I'm going to start demonstrating how we can further narrow this down, similar to how we did in those test cases. So the first thing I want to look at here is I'm going to pull all of the content items here now that have a content category of JPEG. So if you look here, that's going to represent this third or fourth path component here. And it's a little bit more broad than our content item type. So I should expect everything that's a JPEG file to come back, knowing that if I want to then narrow it down to a specific content type, say JPEG files that were generated from an instrument. Now I'm only going to get 2 of those JPEGs back. The other ones were mapped to a JPEG device content type. So we can start to narrow it down, and you can see these queries are pretty manageable. It's a little bit, different getting used to the language, but it's basically a line or two of language here that we need to pass in order to get these content items back. Next thing I'm going to do here is actually pick on one of these. I'm going to grab the identifier for this one from December 4th. And for a moment here, I'm just going to show the related NS day and the ISO date that it has mapped to it so we can prove, okay, it's from December 4th. Now that may not be that useful on its own, but what we can then do from there quite easily is actually take that same content item. Oh, here, hold on. Make sure I get the right identifier here. I'm going to take the same content item though, and I'm going to take a look at all of the content items that share the same ISO date. And you can start to see how easy it is to write these queries as opposed to a more traditional SQL statement, or if we were to try to do the same thing in S3. So I'm going to take the content item that find the NS day and then look back at the relationships that it has to all content items and get all of those back. So now you can see here, I've got not just the original one that I searched for, but I also see a JSON and a zip file that are associated on the same day. And I'm going to take that one step further and say, for the use case that I want to grab all of the content items from this ISO day from that original file that I looked at, but exclude anything that was a JPEG. So you see here, we're going to run the same query, but we're excluding anything that has a content category of JPEG. And now what I get returned is everything from that same day of the original file that I started with that is not the same type of file. So you can kind of start to see the power of the graph query searches and how quickly you can get to what you need traversing that graph. All right, so next what I'm going to do is actually pull up a REST client and hit some of these API paths directly and show you what that looks like. Just a moment here. All right. I'm going to make this a little bit larger so that you can see it. And first I'll call attention to the URL. This is kind of our base URL. You can see it's mapped to a device librarian. But the important part here is the endpoint that I'm going to hit. So I'm actually just going to do a basic search for all content items. And this search is a little bit different than what I was just showing. This is actually going to return all content items regardless of the status. This is querying directly against our local librarian store rather than the global graph database. So right now, you'll see the same files that I've been showing. They're all closed with file, which is why I was able to search them all in our graph database. There we go. So just to prove out, these are all still here. And what I'm actually going to do next is call a basic put here. And this is just calling the basic put operation. So that represents the first part of the content item upload process. All it's going to do is create some metadata and generate a upload URL for me. And the reason why I want to show this is because then I can go back and run that basic search again, and it'll show up there. But when I hit these other search endpoints, it's not going to because it hasn't yet been closed. It's not available in our global graph. And so I just wanted to demonstrate that here briefly. So you can see here, our content item was created. It gives us some upload specs. This is actually my upload URL right here. And I'm going to go back now and hit this again. And what I can show is that we should have one file now. And I didn't really go over this, but I mapped this to a content, to an NSD, sorry, for today. So it's going to be distinct from all of the other content items that I've put. So we'll go look for that one here in our results. And one easily distinguishable factor is that it's going to be in status created rather than closed with file. So we see all of our original content types. Here's our new one that's mapped to today's date. And you can see the status is created. So when I go to do another search, which is hitting our API operation that's called Search Librarian, this is actually going to reach out to the global graph and retrieve all of the content items that way. So if I run this search, that's going to look for anything with an ISO date greater than December 1st, 2022. That would include the new content item I put, except that it's not actually closed with file yet, so it's not available in our global graph. So I just wanted to kind of demonstrate the difference in these different search capabilities that way. So right now I'll get everything from December of 2022, but I will not actually get back the file that I just put, or the content item that I just put. As I get this to load. Oh, that might actually be all of them. But you can see that that new content item is not available here. All of these are closed with file. And the last thing I wanted to show, this is just a simple search parameter, but you saw in our integration test cases that there were actually ways to pass multiple different search parameters. So I just wanted to show kind of what that looks like. We're going to pass a similar query to what I showed at the end of our graph query searches, which was looking at this ISO date of December 4th, 2022, for anything that does not have a content category of JPEG. So you can see I passed two different search parameters here, and we just AND them together in a list. So I'm going to run this, and I should expect those same two, the JSON from December 4th, as well as the zip from December 4th, but it's going to exclude that original JPEG. You can see I can kind of get at the same information that I did through the graph query. The difference is I had to directly pass the date as opposed to, starting from that original content item and just getting everything else that had similar metadata to it. So that kind of demonstrates some of the search capabilities of our librarian. The last thing I wanted to touch on here briefly was looking a little bit more at some of our documentation. So we have sort of an API description here where we give all of these different methods and endpoints. There's a basic search, there's a search by graph query, but I'm going to pick on this last one that we just looked at. Just to give you an idea of kind of what the documentation looks like. You can see here exactly how you would pass that search information. We give the REST path, the REST method, as well as some example payloads that we would want to send, including the basic search, as well as our more complex search parameters. And that is my demonstration of our librarian. Brian, did you have anything else you wanted to close out with before we wrap up for the day?
No, that was great. I'm going to go back to the screen here. So we talked about moving some, we demonstrated moving some large files around. We definitely talked about using the access URLs. We saw a bunch of those are big blurry things. We really spent a lot of time talking about, how we make files belong to this graph, right? I think we talked about the search you want is not in the path. We definitely demonstrated that we can execute lots of searches. And really the trick is we're searching inside our own state stores. We're not searching inside S3 directly most of the time. And we'll cover entity-based security in another demo. So I think we got through all of it. If you're interested in using the librarian, feel free to reach out, neuronsphere.io. Thank you.